Hey everyone, I welcome you all to my session today in Omaha Azure user group meeting for the month of March 2023. Today we are going to look at running Kubernetes in Azure. Before we jump onto today's presentation, let me quickly introduce myself. My name is Vaibhav Gujral. I'm based out of Omaha since 2016. Before that, I was in India. I work as a director in Microsoft Cloud Center of Excellence at Capgemini. I'm been awarded Microsoft Azure MVP since 2020. I do hold several certifications, including Microsoft Certified Azure Solutions Architect as well as AWS Solution Architect Associate. With that, let's quickly jump onto today's presentation. We will start with the very basics. We'll look into Kubernetes at a high level for the benefit of people who have not worked on Kubernetes in the past. Then we'll see how you can run Kubernetes in Azure using managed offering called as AKS.
Kubernetes is a container orchestration tool. If you have hundreds and thousands of containers running in your production workloads, then you really need to go and look into a container orchestration technology. Kubernetes is one of them. It's the industry standard now. It has become the most popular, but there are others like Docker Swarm, which you can look at as well. So in a nutshell, it's a portable, extensible open source platform that you can use for automating the deployment, scaling, and management of containerized workloads. Kubernetes, there are different people who pronounce it different way. I like to pronounce it as Kubernetes. I've heard people who call Kubernetes and several other pronunciations. I'm okay with anything, but to understand it comes from a Greek back word called Kubernetes, which essentially means helmsman of a ship. And that's why in the logo of Kubernetes, you will see it has that steering of a ship. Okay, a little brief history about Kubernetes. It was originally uh, developed by Google, and they announced it in 2014 when they released it uh, for their internal use. They had a system known as Borg. It was a big project they used to use for their release management. So Kubernetes was based on top of that. Originally, anyone who is a Star Trek fan here? Star Trek? Anyone? So there was, I'm not, but there was a Borg character called as Seven of Nine. So loosely, Kubernetes is based on that. That's why its internal name was originally Project 7 before they branded it as Kubernetes before releasing. And fun fact is, if you will look at the logo of Kubernetes, you will see there are 7 spokes in that wheel. So it essentially represents the Project 7. So, anyways, version 1 was released in 2015. Current version is 1.26.1, and which was released in January. In April, they are releasing version 1.27. And it was originally written in C++, but they have now rewritten it in Go language. So a very high level picture when you're starting with Kubernetes. So it all starts with a Kubernetes cluster, and a Kubernetes cluster has 2 main components, a control plane and a worker plane. Control plane runs your master nodes, which could be your physical servers, virtual machines, and the worker plane runs your worker nodes. Your control plane runs the actual Kubernetes core services, which makes Kubernetes, which holds all the glue and magic behind Kubernetes. And you, as a consumer of Kubernetes, you provision and run your workloads and application on worker plane. To make this work, there are several components running in both control plane and worker plane. In control plane, there are 4 main components, starting with API server, scheduler, etcd, and controller manager. And in worker plane, there are 4 main components. One is kubelet, kubeproxy, the container runtime, which runs your containers, and the actual pods or containers. So starting with the control plane, API server is the front end for your Kubernetes cluster. It is the entry point for your Kubernetes cluster. Without setting up your API server, you cannot communicate with API with your Kubernetes cluster. All your components inside Kubernetes cluster can also not talk to each other. They all talk to each other as well using API server. Controller manager runs the controller processes. There are different objects that you can create in Kubernetes. Clusters like deployment, stateful sets, daemon sets. You can create your pods. Each of them represents a pod inside a Kubernetes cluster. And to maintain the life cycle of each of those objects, there are several controllers which are managed by controller manager. Scheduler sole job is to track any newly created pods and ensure that they get appropriate nodes, worker nodes to run them on. And lastly, HCD, it's the persistent data store, which behaves as a memory. So anything that happens in Kubernetes, whenever API server is called, the very first action that it does is it goes to HCD and writes the state of Kubernetes cluster before performing that action. Likewise, on the worker node, as I said, pod is a abstraction on top of your containers. So you can write Docker containers, but you don't run Docker containers plainly inside your Kubernetes clusters. You wrap them in what is known as a pod, and then you run those pods on top of a container runtime. It could be Docker, it could be containered. Kubernetes initially used to come packaged with Docker container runtime, but now they come with containered after Docker went into licensing. And then kubeproxy and kubelet are the other two components that run in the worker plane. So kubelets are the agents that run on each node inside a cluster to ensure that your clusters are running, your containers are running inside the pods, and your kubeproxy is the component which ensures that the networking is set up between the different pods and the nodes, and they can talk to each other. You can have Docker containers in Kubernetes. You can run Docker containers, but you don't run containers per se. You have to wrap them up in pods, and you run pods inside Kubernetes. You don't run containers per se, but you can still wrap those and run those as pods inside. There is no container object in Kubernetes. The object is called as pod, and pod can have one or more than one containers. Yes, I mean, ideally, you will like to have only one container running inside a pod, but there you cannot rule out situations where you might like to run multiple containers inside single pod. I've never run multiple containers inside single pod, but that being said, there is a possibility that you can run multiple containers inside a pod. So before we jump onto AKS, since this presentation is on AKS, I wanted to bring everyone up to speed on some of the terminology and concepts in Kubernetes so that when I talk about few things, you don't get left out and you know what I'm talking about. So to start with, as I was saying, pods are the smallest units in Kubernetes. It's an abstraction over containers. So you don't run containers, you run pods in Kubernetes, which are an abstraction on top of containers. You have services which provide a persistent IP address on top of your pod so that they can talk to each other, and you can have things like load balancing on top of that. Ingress, as the name suggests, helps you implement HTTP and HTTPS routes so that you can talk to your Kubernetes cluster from outside over HTTP and HTTPS. Config maps and secrets are for your configuration. If you have worked on any application, you store your configuration somewhere. So all textual configuration can go in config maps in Kubernetes, which is nothing but a key value pair. If you have secrets that you want to store inside your Kubernetes cluster, those should not be stored in config maps because it's stored in plain text. Instead, you should utilize secrets, which are meant for storing your secrets inside Kubernetes. Volumes are for storing your persistent data. If you are running your pods and nodes inside your Kubernetes cluster, there are situations where you also want to store your data somewhere in a persistent form so that even if something happens to your Kubernetes cluster or your pods or nodes, you can still be able to go back and read that data. For that, you use volumes. Then there are different deployment models when you are creating your services and application workloads in Kubernetes. There are different ways you can do it. To start with is a replica set. So when you are creating your workloads or provisioning your workloads in Kubernetes, you define how many replicas of your application needs to run in Kubernetes cluster. So that defines the replica set inside a Kubernetes cluster. Then uh, there are two different objects that you can use to deploy your applications in Kubernetes. One is known as deployment, the other one is known as stateful sets. So in deployments are used for stateless applications like your web application, the web layer, or the business layer if you want to run in there. Whereas stateful sets are meant for the applications which are stateful. For example, your databases, if you want to run your databases inside your Kubernetes cluster. So in such situation, you will use stateful sets to provision your database inside Kubernetes. A daemon set is for running background tasks inside your Kubernetes cluster. Then there are a couple of jobs that you can run to handle some of the utilities inside your Kubernetes cluster to support your actual application and workload. At a high level, I did talk about the control plane and worker plane. And as I said, API server is the entry point for your Kubernetes cluster to talk to it. There are three main ways you can talk to API server. As a consumer, you can either make API calls to your Kubernetes API server. There is also a Kubernetes dashboard. Once you set up a Kubernetes cluster, it also exposes a Kubernetes dashboard, which is a UI-based portal that you can use to perform operations on your cluster. And the third is the command line based option, which is known as kubectl. People call it kubectl and through several other means, but it's the command line that you can use as well. And kubectl or kubectl is the most common way how people interact with Kubernetes cluster. But regardless of which option you opt for, API, portal, or command line, it since Kubernetes is declarative in nature, you declare the state of your Kubernetes cluster, and Kubernetes components go ahead and ensure that your Kubernetes cluster maintains that state. So to that declarative state is defined in YAML format. So if you're not aware of YAML, head out to website called yaml.org and you can learn about how YAML schema works. But the idea is you provide your Kubernetes cluster schema file or the configuration file in YAML format through either of the ways that's listed there, and UI or API or command line, which passes the instructions to API server, which stores the instructions first in etcd, and then goes ahead and works with other components to bring the cluster up to speed and at the same state that you are expecting the cluster to be in. So I've listed a link down there from GitHub. So far it might sound pretty easy that these components, we can go ahead and set up these components and get our Kubernetes cluster working up and running. But it's easier said than done, because if you start setting it up, it might take you hours, days, or probably weeks to get your Kubernetes cluster up and working from scratch. If you don't believe me, you can go and head out to that list. There is a gentleman called Kelsey Hightower. He is very renowned in Kubernetes world. He has this GitHub repo where he has detailed all these step-by-step instructions, how you can set up your Kubernetes cluster and all the individual components on your own from scratch. He has given the example on GCP virtual machines, but you can utilize those steps for virtually Azure virtual machines or your physical servers or anywhere. But the idea is if you will go through those steps within few minutes or within an hour or so, I'm pretty sure you will understand that it's not as easy as it appears to be. Setting it up, it's a big deal, and that's where all the managed offerings come into place. All the managed Kubernetes offerings, and AKS, Azure Kubernetes Service, is one of those where you can run your Kubernetes clusters inside Azure platform. And it's just not running your Kubernetes cluster, it's a managed Kubernetes offering. So Microsoft takes away lots of pain from managing and setting up your cluster like any other platform as a service. So As I said, it's a hosted Kubernetes service in Azure. It reduces the overall complexity that is there in setting up your cluster, so that developers and all the development teams can focus on the stuff that really matters, so that they can write their applications and run. Uh, the core piece of the core aspect of any managed Kubernetes offering, including AKS, is that the control plane is actually managed by the cloud provider. So you don't have to really worry about setting up control plane or any of the components like API server, etcd, and so on. They are automatically provisioned for you when you create an AKS cluster. And the best part is you don't pay for that control plane. Microsoft is going to manage the scaling, the patching, upgrading the control plane on their own. And you only pay for the worker node when you are creating an AKS cluster. I will show you in a demo how you can get started. But the one of the inputs you have to define there is how many worker nodes you want in your node pool inside AKS cluster. That's it. And Microsoft goes ahead and within 3 to 4 minutes, it provisions the full control plane and spins up the node pool for you for worker nodes and hooks it up to your control plane, and you are all good to get started with. So just to give you a highlight, like there is in AKS offering or in any managed Kubernetes offering, the control plane is managed by the cloud provider and the worker plane is managed by the customer. But that being said, it's a platform as a service, and like any other platform service, it works on a shared responsibility model. Unlike what you see on the left is do-it-yourself Kubernetes cluster, where you own end-to-end everything from clustering, from upgrading, patching, running your applications, and so on. Some or most of these responsibilities are handed over to cloud provider when you go to a managed offering. Some of the benefits that I mean, it's not just specific to AKS. That's true with most of the platform services. As I said, they cloud provider automatically manages automatic upgrades, patching, and so on. You get scalability, high availability, because they have algorithms and automations in place to ensure that they can meet the SLA and keep your control plane up and running. And the best part, as I said, there is no extra charge for using your control plane. So there are 5 different ways you can get started with AKS. You can create your AKS cluster using CLI, Azure CLI. You can create AKS cluster using Azure PowerShell. You can also use REST-based management API that Azure offers to create AKS cluster. You can also go ahead and create an AKS cluster in Azure portal, which is the UI-based portal. And last but not the least, it's an ARM resource. It's an Azure Resource Manager resource. So you can utilize ARM templates and Bicep as well to provision your AKS cluster. There is no distinction between which way is better than the other. It's totally up to you and your organization to decide what tool set you would like to opt for. Personally, I like using Azure CLI when I'm working on my Azure environment because it sounds way easier for me to adopt as well as use. So just to put things into perspective before we jump onto a quick demo to see what the different features that AKS offers, just imagine when you have to set up a Kubernetes cluster, how easy it becomes with a managed offering like AKS, where you can simply go and execute a command AKS create and provide parameters, and bingo, within 3 to 4 minutes, your AKS cluster is up and running. Just imagine if you have to follow Kelsey Hightower and you have to go ahead and set up the same thing on your own. It's going to take at least a day or two for you to get the bare minimum server started. Likewise, if you have to upgrade, you have to scale, all those operations become super easy with a managed offering like AKS. So with that, let me quickly jump onto my Azure portal to showcase an AKS cluster. You see my portal here. So is it too small or is it okay? Okay. So what you see here is I already have a resource group created here. In that, I have created a couple of resources. I have created an Azure Container Registry, which is a repository for storing your container images. And then I have also created an AKS cluster, which is right here. So as you will see, it's an AKS resource. It says Kubernetes service. On the overview page, you can see all the resources. If I go to my terminal here, let me show you what I did. So I did logged in into my Azure cloud. I did went ahead and choose the subscription. I did created a resource group of my choice. And then I went ahead and created my ACR, which is the Azure Container Registry. And I'll show you the reason why I did that before creating my AKS cluster. And this is the whole command which I executed for creating my AKS cluster. So it was az AKS create, and I provided the resource group name, the resource group that I created above, the name of my cluster, and node count. I just wanted one to keep my cost low, but in production, in real world production scenarios, it might be hundreds or thousands. There is, I think, a limit of 5,000 nodes that you can have. You can check the subscription and quota page for details. And then I have enabled monitoring on my cluster. And here you see the attached ACR command. Oops. No, it was written in C++. Now it's written in Go. Go language. There's a language called Go. I I don't think so. It's not proper. I think it's open source, maybe.
It's open source, you can use it with, it's not only specific uses like this. I've seen clients with like AWS cloud, big go as well. So it's not people use it, it's a backend language, so.
So this was the thing that I did before coming to the presentation to save time, because otherwise it takes roughly around 4 to 5 minutes to provision the AKS cluster. To save those 5 minutes, I already executed that. And that's what you see here in Azure portal. I have the AKS cluster created here. As you can see, Kubernetes provides its own dashboard that you can connect to outside of Azure portal. But the advantage of using a service like AKS is that within Azure portal, they also provide you a very good snapshot of your cluster. So if you will see here, I can go inside namespaces and see what are the different namespaces created within my AKS cluster. What are the workloads running inside my AKS cluster today? And right now, which services I am running today, which ingresses I am running today, right now. If I have hooked up any persistent volume to my nodes, and what is my if I have any config maps or secrets hooked up into my Kubernetes AKS cluster. And as I was saying, we can connect to this using kubectl. So I already have Azure CLI. Let me. So let me see if I already have. So right now I'm running Docker desktop in my laptop. So if you're not aware, you can actually enable Kubernetes in your Docker desktop, and you can play with it rather than setting it up a full-fledged Kubernetes cluster. So if you are not aware of, if you'll go to Kubernetes, to Docker desktop and go inside settings here, you will see a tab for Kubernetes, and you can go ahead and enable Kubernetes here, and it will create an instance of Kubernetes for you so that you can play with it. And since I'm running there, it also installs kubectl for me because it has enabled Kubernetes on Docker desktop. And that's what you are seeing here, that right now I only am connected to one single instance of Kubernetes cluster, which is running in my Docker desktop. And that's the only context available. So if I go ahead and do kubectl get pods, so right now it's going into my Docker desktop Kubernetes instance and saying there is nothing that is running right now because I just cleaned it before coming here. So there is nothing, and I'll show you when it comes up. But what I want to show is how easy it is to get connected to Azure Kubernetes service now. Since it's a part of Azure ecosystem, it has seamless integration with Azure Active Directory. I have a couple of slides on identity and access management as well, but I want to go ahead and use a command, which is AZAKS get credentials, which essentially goes ahead and verifies my Azure AD credentials and gets me a context so that I can connect to my AKS cluster. So let me go ahead and quickly grab that so that I don't mess it up with my commands. I'll go inside my terminal. As you see, AZAKS get credentials. I provided the resource group name and my name of the Kubernetes cluster. And as soon as I enter, it will go ahead and create a context for me. If I go ahead and execute get context again, you will see now I'm connected to my AKS cluster. kubectl get pods. There is nothing running there as of now because it was a blank cluster. So let's go ahead and create, uh, let's say, a deployment there. Let's create an Nginx one, and we can use the image which is available in Docker registry public repository. For Nginx, you can also hook it up to your own container registries, which are private, like the ACR that I created, and I'll show how you can do that. But if you don't provide an ACR, it will automatically go ahead and connect to Docker public registry and download the image. So as you see, it went ahead and it downloaded the Nginx image and created a deployment for me. So if I go ahead and do get deployment, so you can see my Nginx is there. If I go ahead and do kubectl get pods, here's one of my pods which is running. I can go ahead and very well edit my deployment. Nginx. It will open up my YAML file, which got created for my Kubernetes cluster. I'll go ahead and edit it. Let's say it has one replica. Let's change it to 2. And I'll exit and save it. And it got edited. The changes got saved. Let's see how many pods are there. So you will see it added one more pod for it as soon as I made the changes. But since it's Nginx, it just installed that web server. I cannot really go ahead and access it. The reason being because there is no load balancer service or no ingress egress service that is created. And I can verify that here. As you will see, there is only one cluster IP Kubernetes service, which creates an IP for my Kubernetes cluster, but it doesn't connect to my workload, my Nginx. So I can essentially go ahead and create that service for myself, which is of load balancer type. So essentially what I'm doing is I'm exposing a service of type load balancer on my Kubernetes cluster, which connects back to my Nginx deployment. So if I go ahead and do kubectl get services, as we'll see, my load balancer service is created, but it is still pending on an external IP. Let me go ahead and fetch it again. It did provision an external IP. And if I go here and pull it up, and the port was 8765. I'm sure 8765 should pop up. In the meantime, if I go here and refresh the workloads, you will see the Nginx workload that got created here. I can go ahead and look into the service that got created here, Nginx service. So it's as easy. Within minutes, you can get started. I'm not sure why this is not coming up. 8765. Okay, I think it will come up, maybe a network glitch. But with that, let's quickly move on to the presentation so that I can cover the content. There are a few concepts that I wanted to touch upon when you're working on AKS to give you a good insights into what the power that comes with AKS. One of the aspects is networking. When you are setting up your Kubernetes cluster, networking is a key consideration. And when you are setting up AKS, there are two different ways you can set up your networking inside your Azure Kubernetes service cluster. And you have to think about a node, and your node will run your multiple pods, and how your nodes interact within your worker plane, and how your pods within a node interacts within themselves, how your pods running in one node talks to the pods in other nodes. You have to talk about consider all those networking aspects and plan your networking approach. The very first option that is available in networking is called as kubenet networking. So what essentially you are able to see my screen, right? So what I'm showing here is a worker node, which is running two different pods. One pod is running my database, one pod is running my app. And I also have provisioned a virtual network with a subnet, which is hooked up to my AKS cluster. So by default, every node and every pod gets an IP address in AKS cluster. Under kubenet networking, what happens is each of my pods gets an IP address from a CIDR range that I define inside my node. So here, for an example, I have chosen 10.10.0.1/16. So any pod that gets provisioned inside this node gets an IP address from this CIDR range, and my node gets an IP address from the virtual network. So if I have multiple nodes running in my cluster, so each of those nodes will get an IP address from the sub range, but each of those nodes will define their own CIDR range for their pods, and the pods running inside that node will get IP addresses from only that CIDR range. So any challenges that you see here, now all the pods, let's say running in the first node, will be able to talk to each other. But the challenge here would be if your pod running in one node wants to talk to the pod running in the other node. Technically, they are part of the same cluster, so they should be able to talk. But since both of them belongs to different CIDR ranges, they cannot talk to them straightforward in a straightforward fashion. So to fix that problem, what Microsoft has come up as a solution is they let you create a route table, which gets automatically created for you. So what happens is in that route table, they define inside this node, this is the IP range. Inside this node, this is the IP range. They have done all that mapping in that route table. So what happens is all your pods running in different nodes become aware of each other so that they can then start talking to each other. The other option is called as Azure CNI, the Container Networking Interface option. So it's slightly different from the previous one. So taking the same example, if you have a pod which have two, if you have a node which have two pods running in, one running your database, one running your app. As I said, each pod and each node will have its own IP address, and there will be a subnet attached to your AKS cluster. So in this example, the node will still get the IP address from the virtual network. But the only difference from previous approach is that in this scenario, your pods also get an IP address from the virtual network subnet. So what happens is if there are multiple nodes and each of those nodes have multiple pods, each of those nodes and pods get the IP address from the same virtual network. So there is no extra need for maintaining an extra route table. And since they all are part of the same subnet and same virtual network, they can talk to it out of by design rather than creating a need to create a route table or any other mechanism to ensure that there is a routing available between those. Security, another aspect that you should consider when you are designing your AKS cluster, since AKS is part of Azure ecosystem, it has integration with different Azure security services. You can securely govern your AKS environments using services like Azure policies. I have slides for each of those. I can walk through those as well. But essentially, you can maintain governance of your AKS cluster by implementing policies so that all your AKS environments are compliant. You can utilize Azure Active Directory. That's the best part. If you are using Kubernetes cluster outside of Azure, you can utilize Kubernetes RBAC. You can create your own users and roles and manage those. But since it's part of Azure now in AKS, you can also utilize Azure Active Directory to maintain role-based access control. Anything that gets stored inside Kubernetes cluster, it's all encrypted. and you can use Microsoft managed keys to encrypt it, or you can also provide customer managed keys. In case you provide customer managed keys, you can also store those keys in Key Vault. So there is a seamless integration between Azure Key Vault and Azure Kubernetes Service. It's all by design. And then it's now called Azure Defender, but Azure Security Center, it used to be called before, and it has seamless integration with AKS. So anything that's happening in your AKS environment is automatically captured in Azure Security Center or Azure Defender for Kubernetes, its new brand name. So in that, it does captures everything that's happening in your AKS cluster, and it helps you maintain security posture and gives you alerts and recommendations if you need to change anything in your cluster to improve your overall security posture in that environment. And as of when I was talking about API server, it was the entry point to your Kubernetes cluster. Likewise, in AKS, by default, when you create your AKS cluster, your API server is accessible over public internet, but that's not a very secure, and I would not say not insecure, but I would say it's not a recommended, or it's not a preferred approach by most of the organizations. So because they generally want to run their resources in public cloud inside their private virtual networks. So there is an option. You can run your Azure Kubernetes service inside your private virtual networks, and you can enable a service known as private link or private endpoint, which essentially creates a private IP address and private endpoints for your AKS cluster. And then it becomes a private AKS cluster rather than exposing everything on public internet. Last but not the least, there is an offering called Azure Application Gateway that you can use with several other services, but you can also integrate it with AKS as an ingress controller, which is just a checkbox that you can check if provided you have an application gateway resource created. So like any other resource in Azure, this is what I was saying, the seamless integration with Azure policies. You have your cloud architect or cloud engineer who goes ahead and defines the policies that the AKS environment needs to comply with. Then your development teams and your operation teams go ahead and provision those AKS resources. And as soon as there is anything that is not compliant, the report is generated and can be read by the cloud architect or engineer who provisioned the Azure policies. And this is not different from applying Azure policies on any other Azure resource. Identity and management, as I was saying, you can utilize Azure Active Directory to implement identity and access management inside your AKS cluster, which is the biggest win when you go ahead with AKS. Now, just to give you an insight, in Kubernetes, by default, it comes with a Kubernetes role-based access control where you can create things like roles, cluster roles. You can attach those to bindings, then you can attach users to those roles and role bindings to give them access to specific resources inside your cluster. But AKS takes it one step further. Now you can actually integrate Azure Active Directory with your Kubernetes RBAC. Then you can directly give access to your Azure AD users and groups to your AKS cluster. And that's just not limited to that. Microsoft has also created specific role-based access control roles inside Azure so that you can go ahead and give permissions to your administrators who can go and maintain your AKS clusters. Like there are roles like Azure Kubernetes Service RBAC Reader or Azure Kubernetes Service RBAC Writer who can go and do specific operations. Earlier, without Azure Active Directory and without Azure RBAC, these features were not available as part of Kubernetes RBAC because Kubernetes RBAC only works inside the cluster. I did have shown you the command AZ-AKS get credentials, how I get connected to my AKS cluster through kubectl. Why Ideally, when you are logging in for the first time, it will give you a pop-up if you have Azure AD integrated to your AKS cluster, and there you will log in using your Azure AD credentials, and it will generate a token and it will give you access to it. But since I was already logged in into my Azure environment through my Azure AD credentials, that's why it didn't pop up. But that's one of the advantages you get out of integrating Azure Active Directory with AKS. Now, there's a concept called workload identities, which has been announced in Kubernetes last year. It's just not limited to AKS, but it has been on all the Kubernetes offerings. It is now supported in AKS as well. Earlier, there was a preview feature known as pod identities, which were created as a means where your pods can get a managed identity assigned to them so that then they can take that identity and go ahead and access any of the other Azure resources. Now that is being getting replaced by what is known as workload identities. They are still working on all the full-fledged documentation, but it's not specific to AKS. It's being, as I said, it applies for all the different Kubernetes offerings. To give you a perspective, when you are talking about identities, there are different kinds of identities in any identity platform. One are user identities and then are machine identities. Within machine identities, it could be devices that you use to log into your systems, like phones or laptops. And then there could be applications, which are the actual service principals. So the workload identities in Kubernetes or in AKS refers to all those service principals that you create, and then you either connect them to your AKS cluster so that your AKS cluster can gain access to other Azure resources. Scaling, by default, when you create AKS cluster, you remember I have provided only one node count in my AZ AKS create command. But when I'm running production workloads, I need my worker nodes to scale up and down based on the demand. So by default, when you create AKS cluster, it comes with manual scaling, but you can go ahead and switch it to auto scaling. Obviously, it impacts your cost because depending on the load, it scales out and scales up and down the number of nodes. So just that's a consideration. But if you opt for auto scaling, there are two ways auto scaling works. It could be horizontally or it could be a cluster level auto scaling. So when I say cluster level auto scaling, what it essentially does is it keeps a track of all the pods and see if there are underlying nodes available with all the resources on which those pods can be run or not. In case they are out of nodes and they need to provision additional nodes to run the additional pods on those, the cluster autoscaler goes ahead and provision additional nodes so that those additional pods can be run on those. Now, provided if you already have resources in your nodes provisioned, there is excess capacity, but you still need to provision extra pods to handle the request. For example, if you have e-commerce websites which are running in Kubernetes and you have sales events, so during those times there might be events where your pod number of pods can go up and down. So you can utilize something like as horizontal pod scaling, which scales your number of your pods up and down depending upon the number of requests. Another concept is Kubernetes based event driven scaling, which is called as KEDA, where you can, instead of auto scaling, the options that I shared in the last slide, you can actually scale your AKS cluster based on events. You can listen to different events, and based on that, you can scale your nodes and pods. I provided a link down below there. If you are interested about reading more on that, please go and check it out. Monitoring, there is an offering called Azure Monitor in Azure, which you can utilize for monitoring most of your Azure services, platform, as well as infrastructure services. It does supports AKS. The offering is known as Azure Monitor for Containers and Container Insights, through which you can get all the insights into what's happening in your AKS cluster. And you can find details for your pods, for your nodes, for your controllers, for your containers that are running in your AKS cluster. And anyone has set up diagnostics in any of the platform services or infrastructure services in Azure? If you go ahead and create any Azure service in Azure, there is a tab to the very bottom called as diagnostic settings. So which enables you to export the diagnostic logs for your service into an event hub or a storage account or a log analytic workspace. So that is supported by AKS as well. So if you are in a situation where you would like to export your diagnostic logs out of your AKS cluster into a storage account, event hub, or a log analytic workspace, you can do that. Lastly, I did talk about persistent volumes in one of the slides initially, one of the concepts that you should be aware of in AKS. When you are in need of having a persistent volume attached to your pods or nodes, you can either choose Azure Managed Disk or you can use Azure Files. Both of those offerings can be used as persistent volumes. You can use persistent volume claims then to ensure the persistence of your data. I would probably just skip that. We did touch about Azure Container Registry, which is a private registry that you can create in Azure to store your container images, and then you can attach it to your AKS cluster so that your AKS cluster can pick up images and run your pods directly from them. Now, one of the questions I have heard so many times is people get confused that when they have containerized workloads, they always assume that if something is containerized, it is supposed to go and run in Kubernetes. That's a very big myth. It's not like that. There are applications, there are workloads which don't really need bustable container instances, meaning they don't need hundreds and thousands of container instances to support. Whereas there are applications and workloads which are very small, they can run in one or two smaller container instances. To support exactly that scenario, there is a service in Azure known as Azure Container Instance, where you can, let's say I just have a small single web application which I want to run in my container. I can just spin up a single container instance and that will do pretty much what I need out of it. I don't really need to pay anything for AKS. I don't have to worry about maintaining that. And the life cycle also becomes very easy. You publish your image to Azure Container Registry, and then you deploy it to Azure Container Instance. Now, this is an offering that you as a consumer can use, but then there is also an offering within AKS, which is built on top of ACI, Azure Container Instances. They call it as serverless Kubernetes with virtual nodes. So essentially, the idea is that you can spin up multiple virtual nodes on the fly in a serverless fashion, which are built on top of these ACI offering, where you can spin up these smaller container instances on the fly in a serverless fashion. Azure Container Apps, heard of it? Anyone? This is the most recent announcement. I think sometime last year they announced a new offering in the container space. So it's built on top of AKS, but they are promising that it's more of a serverless of Kubernetes offering where you can run your microservices based architecture in Kubernetes in a pure serverless fashion. So I strongly recommend you go and check it out if it fits your use case. So with that, let me exit this and show you a quick demo, and then we can wrap up today's presentation. So I have an application here running locally. If I go ahead and run it here in Visual Studio, I'll show you it's a plain simple application. It pops up a web page. What essentially it's doing is it's fetching the machine configuration. Like if you will say it's fetching my MacBook's configuration here. It's fetching the host machine's configuration and showing it on the page. So this is pretty much when I run it locally. I can go ahead and package it and run it in Docker as a container. I can go ahead and package it and run it in local Kubernetes in my Docker desktop instance. And I can also go ahead and run it in my AKS cluster as well. So let me quickly go ahead and clear this. Let me see if there is. So right now the image is still not created. So what I'm gonna do is I'm going to build my Docker image, push it to Azure Container Registry, and then I'm going to apply my changes on Kubernetes cluster so that my application can run in the AKS cluster. So to do that, I will first go ahead and build my image. So if you have used Docker before, you can directly use Docker build command. But if you are a Mac user, when you build using Docker build command, it generates Mac specific binaries. And if you deploy that image to AKS in a Linux environment, it doesn't work. That's why you have to use docker buildx command so that you can specify the platform against which you can target your image. That's the whole reason I'm using that. Otherwise, you can simply use docker build command as well. So as soon as this is done, this will add an image to my Docker images repository locally, and then I'll push it into a ACR. See. Anyways, this was the Nginx instance that was taking time, but it popped up once I've added the load balancer service in the previous demo. It should be done within a few seconds. So any questions so far? Anyone? I guess no. Either everyone understood everything or no one understood anything. Yeah, it's pretty cool, and it's so much to learn in Kubernetes overall. And one thing you will notice is when you okay, this is done. So let me go ahead and tag my image, and let me pull Docker images. So this was the image that was created after building it, and then I have tagged it with my ACR so that I can push it to my ACR. I'm gonna go ahead and push it. Using Docker push command. So this is okay. I need to log in. So I will go ahead and log in into my ACR. So I did mention that the latest version is 1.226.1 for Kubernetes, and 1.27 is getting released in April. So you will notice to create an AKS cluster. The AKS cluster runs 2 or 3 versions behind the the latest Kubernetes version. Can anyone tell me what could be the reason for that? So if I go back here in Azure portal, and if I go ahead in cluster configuration, you will see that it's running on 1.24.9. And if I go ahead and click on update version, it only gives me an option till 1.25.5, whereas the current version is 1.26.1. So I'm pretty sure it is 2 or 3 versions behind schedule. So any guesses why it's like that? That is right. That is right. I mean, the version is Kubernetes version is out there. So if you are setting up a Kubernetes cluster from scratch, you can use 1.26.1. But any of the cloud providers, when they have to support a specific version, they have to wait for the release. Once it gets released, they have to go through their testing schedule to ensure that everything works in their managed offering before they can make it available for their end customers. That's the whole reason why you don't see it. And that's true. I mean, because they have to ensure any of their platform services don't break with the newer versions. So anyways, this is my image that has been pushed to ACS. Let me quickly go ahead and ensure that let me update my image path to ACR, which is here. I'll go ahead and save it. And let me quickly ensure that qctl config get context. That's correct. I don't need to do that. So let me quickly go ahead and here is my Kubernetes YAML command, a YAML file that you will see here. What it essentially is doing is it is creating a deployment for my application, and it's picking up this particular image, which is pushed into my ACR. And it's also creating a load balancer service so that I can access it over a browser on public internet. So this is done. Let me clear this. Let me go ahead and do kubectl get deployments. So Nginx was what we have seen before, and ASP.NET app is the one that we just pushed. Let me quickly go and do pods. So as you will see, there was only one replica. That's why it's running only one pod. Let me do kubectl get services. So here's my load balancer service running, pointing to my app, and it is running on this particular IP address. Go ahead and run it. And as you'll see now, it's running, my app is running in my AKS cluster, and it's pointing to my host, which is this. I can also verify if this is running here or not. I will go back to my workloads. And here is my workload that just got deployed. If I click on that, you will see here is my pod, which is running in here. I can go ahead and see the container within my pod, which I just pushed. And here's the node pool. Since I only provided one node, that's why in my node pool, there is only one node and it says it's in ready state. Cluster configuration, I did touch upon the version upgrade, but there are two different pricing tiers. Earlier, it used to be standard, which comes with an SLA, but now Microsoft has released a free tier, which doesn't comes with a SLA. It does supports most of the features, but there is no SLA, so it's not recommended for production workloads. If you would like to integrate your Key Vault with AKS, you have to go ahead and enable secret source CSI driver. It utilizes this driver to enable the integration with Key Vault. Now, since this is AKS cluster, not a plain Kubernetes cluster, so it just not supports local Kubernetes RBAC. It also supports Azure AD enabled RBAC. That is what you can go ahead and choose under the authentication and authorization. You can go ahead and change your networking options. As I was showing, KubeNet and CNI. Right now it is set to KubeNet. If you would like to change it, you have to provision a new cluster. Once a cluster is provisioned, you cannot change the networking scheme. You can enable HTTP application routing here. And remember, I was saying application gateway can be integrated as an ingress controller for your AKS cluster. So for that, you can go here and enable ingress controller, and provided if you have a gateway already created. If not, you can create new one here. If you have a private cluster, it will show up here. That also, once you create a cluster, you cannot make it private. You have to define it as a private cluster at the time of creation. If it's private, it will show here that it's enabled. But you can also restrict access to your Kubernetes API server to specific IP ranges by providing IP ranges under the authorized IP ranges here. You can integrate with Open Service Mesh. Anyone has idea on what is GitOps? So basically, you can include provisioning of your AKS cluster and deployment of your workloads in AKS cluster in your CI/CD pipeline. And all the best practices are included in the concept called GitOps. There is several material out there, and if you are in DevOps transformation phase, you should check it out so that you can implement GitOps pipelines. And last but not the least, here are the policies. I don't have on my demo cluster create enabled, but you can go ahead and enable it. And then if you will go here in policies, you can go ahead and assign those policies to your resource groups and subscriptions, which has your AKS cluster. And as soon as someone breaks that compliance, it will be visible in this dashboard here. With that, CI/CD is a key component in any organization today. So if you are going to adopt AKS, you can integrate it with any DevOps tool of your choice. If you are using Azure DevOps and Azure pipelines, you can integrate it with AKS. If you are using GitHub and Jenkins, you can also integrate it with Azure Kubernetes service. The idea here is that it supports most of the popular DevOps tools. So it should not be a problem integrating it with AKS and provisioning your workloads. If you come from Kubernetes background, Helm's Package Manager is a tool set you use to manage packages within your Kubernetes cluster. It is also supported in AKS. Nothing changes for AKS. Before I wrap up, I wanted to touch upon few best practices if you are provisioning your AKS. And these best practices are published by Microsoft. I provided the link there, and they keep on updating those. But some of the key ones here is that when you are defining your network topology before creation of your cluster, please consider which topology you want to use, KubeNet or CNI. What is going to be your identity management approach? Are you going to rely just on plain Kubernetes RBAC, or are you going to integrate Azure AD or not? What are your scalability and high availability requirements? Because based on that, you will define your scaling criteria. You can go with manual scaling, you will define auto scaling, you will go with event-driven scaling. That's a consideration you should have before you provision a cluster. Secure data flow. Security is a key component. It's a no-brainer. It's always understated, but don't overlook security of your pods, of your nodes, of your network communication between those components, how your API server is being communicating to everyone else. Do you need a private cluster? Do you need a public cluster? You have to consider all those things before finalizing on your cluster. And it's a very successful offering from Microsoft Azure. It's been growing rapidly. I think it's the fastest growing service from Microsoft Azure. So if you are interested, I strongly suggest reading that book for which I have provided the snapshot. It's available online on different platforms. You can also buy it from Amazon, but it's a great book. Otherwise, you can also find lots of information on Kubernetes and AKS on Microsoft and Kubernetes documentation. There is a website called kubernetes.io, which details everything about Kubernetes, and Microsoft has published all documentation on AKS. They have also published several reference architectures that you can check. With that, you can reach out to me. I'm pretty active on Twitter and LinkedIn at least, so you can reach out to me if you will be interested. And if you have any questions, we can always touch base. If you want slides, you can use that QR code and grab the slides. And with that, I think that's pretty much I had. And this meeting is recorded, so I will share your session with you so that you can use it. If you want, I can put it in our user group YouTube channel as well. And I'll go ahead and put my recording as well on our YouTube channel. And you can feel free to share yours as well wherever you would like fit. With that, thank you everyone for joining tonight. And I will be very happy if you can pass on the word to the communities and we can see more turnout, because that encourages me to keep doing this. That encourages our sponsors to help us run the user group. So yeah, with that, thank you.